let's do this. Dun, dun, dun. Shh. You guys are loud. I have lots to do. All right, we have 3 different functions: piecewise, step, and exponential functions. Is it late? Or is it?
I was absent.
So you're going to put absent on top? And you're going to go ahead and put it in the drawer that's right behind the computer. It's the 3rd one down. Piecewise. Piece, like piece of pie. Piecewise, step, and exponential. We have 6 examples. Why is there a notebook here? Why is there a notebook here?
Oh, sorry.
I hit record, right? I don't think he realizes that if you don't do it on a separate sheet of paper, I'm not going to what?
I have it. I'm going to do it.
Okay.
I have another thing. I got this. I got this.
Just smile and nod. I think this marker's dead. Ah, that was bad. Shh, shh, shh. What are the key characteristics? Oops. For piecewise. Oops. Step. And exponential functions. Don't forget, Wednesday next week is what? Your test. Thursday and Friday next week is your task. Next week is test week. Thursday, Friday. Sorry, because it's minimum day. Parent teacher conferences are Thursday next week from 4 to 7. Yeah, on Thursday. Also? That's Thursday. Which is Thursday. During third? All right, let's talk about piecewise functions. Here we go. Piecewise function is a function that can be broken into pieces. Fancy that. They are different functions put together. So a piecewise function is a function that can be broken into pieces, and there are different functions put together. So you'll see part of an absolute value, part of a parabola, part of a line, but it's just all flowy together. Okay. After that is step function. All right, step function can be written as a finite linear combination of intervals. When you think of a step function, I want you to think of a staircase. Next is exponential function. An exponential function actually has a function that we're going to see. The function notation is f of x equals b to the x plus h and then plus k. Now you did exponentials in IM1, remember? The only difference though in IM1 is that you did not have all of this. You just had f of x equals b to the x plus k. Remember parent function? What's your parent function? B to the x. What's your k? What's your k? Represent something. Starts with an A. No. Your asymptote? It also tells you what? Some of you look at me like you've never graphed this in your life. Tells you to either go what? Up or down. Up or down. If it's positive, it goes up, and if it's negative, it goes down. What's usually your k? What's starting with your parent function? Your asymptote's always what? Where's your yn? Well, yeah. So it's where? Some of you are looking at me like I'm crazy. Yes? Did you learn parent function? And then K tells you what to do from here. All the points you move what? Either up or down, depending on. Okay? Right? Yeah? Okay. We've added an H. Is anyone writing this? I'm about to erase it. While we're here, though, I'm going to talk. This one here is going from here to here, which is what? It's increasing, so is that growth or decay? Decays which way? The opposite, not decay goes this way. Yeah? What makes it growth? What? It's based on B. Mm-mm.
If it's a fraction.
Fraction makes it what?
Up.
Growth is great when B is greater than 1. When your base is greater than 1, in other words, a whole number. It could be, though, that we have 4/3. 4/3 is bigger than 1, right? So even though it's a fraction, that's still growth because it's greater than 1. B is a fraction between 0 and 1, which means it's then decay. So it's either going to go this way for decay or it's going this way for growth. I feel backwards. Okay? So B is greater than 1 means your base is greater than 1. I don't care if it's a fraction or not, but if the numerator is bigger than the denominator, you have growth. If you are like 1/2, 1/3, 2/3, you are in decay. There is no negative here. Got it? That was IM1 in like 30 seconds. And if you're still stuck, you can look at my IM1 notes later. All right, so exponential function. We now have h. So h is special. This is still your parent function, right? H and k are going to determine. We just said that k is your what? Asymptote. Which is your k. It's the line you what? Can you pass it? Nope. It's the line you never cross. It's always dotted and it's always horizontal. Should it be on your graph? Yep. H is going to tell me something, and so is K. We also said K was the asymptote, but I also said earlier that K also determined what? Whether you moved it up or you moved it down. So remember you, in IM1, hopefully you did this. When you graph your parent function, your asymptote was 0, 0, and your parent function usually went through 0, 1 and looked like this, right? And then K, let's just say K was positive 2, which means at positive 2, is now your asymptote. Yeah? And you took this point and did what with it? You moved it up how many? 2. So now it's going through here. Oops, straight. And it looks like this. When you graphed these last year, your graphs should have looked like that. Yeah? Okay. If they didn't, I'm sorry. But they should have. Okay? And then all we did was we always had 5 points. -2 to +2, and we took those points and we moved them up 2, up 2, up 2, up 2. Right? And then that's how we got our new function. Parent function was always dotted. Your new function was always solid. Correct? Okay, so that determines up and down. Right? H is going to determine left and right. Okay? So remember this point was the starting point every single time for the parent function. What kind of one? Ordered pair. 0, 1. So we're going to write that down. Our starting point is always what? 0, 1. Starting, not starting. Remember, that's your parent function. Right? Okay. So there's my parent function. Okay, so K, we just said, is a vertical shift. That's up and down. Positive and negative. But H is a horizontal shift. Now the only problem with that is that this whole time, H is always what? For vertex form, for absolute value, H is always what? The opposite. So guess what? It's still the opposite. So H is still opposite. It's still going to tell you horizontal shift. It's still going to go negative is that way and positive is right. That's not changing, but you still got to take the opposite. K is never changing. It's always the same. Make sense? Questions here? Okay. I went over IM1 in like 4 minutes, which is like 3 days in IM1. All right, examples. First ones we're going to do are step. So example A. The questions are, how many different pieces are there? And the second question is, use intervals to break up the separate pieces. Remember I said step looks like a staircase in a way. Think of it as a staircase. There's steps kind of going along the way. I do have closed circles and I do have open circles or points. There's a reason for that. For it to be a function, remember it has to pass a vertical line test. And a vertical line test draws a line straight up and down. And if it goes through more than one point, it's not a function, correct? This is still a function because notice this one, it counts as the point. This one does not count as a point, okay? That's why it's open. The function has now jumped to here, okay? So you are going to make yourself a note. When you have a closed little circle, you have a bracket. But when you have an open circle, you have parentheses. Because we're not really at that point when we have a parenthesis, right? Like infinity, we can never really get there, which is why it's parenthesis, but we are there at the closed bracket. Make sense? Oh, sorry. How many different pieces are there? How many? 3. Okay. Oops. 2, 0, 1. All right, use intervals to break up the pieces, going from left to right. Ready? Intervals. Do we use X's or Y's? You use X. So let's go from left to right. What X did I use this? 6. Positive or negative? Negative. Is it bracket or parenthesis? Bracket. So what number is this? Negative 2. Parenthesis or bracket? Parenthesis. Now jump up to the next step. What's this number here? Negative 2 bracket or parenthesis? Bracket. Up to what number is this? X values, guys. 0, very good. Bracket or parenthesis? Parenthesis. Next number is what? 0, 2. Quattro, 4. That's it. Got it? Question? All right, let's do it again. Did I warn you we're taking 3 pages of notes? This is now page 2, and then we got page 3. Don't worry. Oh, no, today. Still the same 2 questions. I'm just not going to write out the questions. Ready to graph. I'm going to change the color so you can see this one a little bit better maybe. How many pieces? 6. What are your intervals? There are 6. So parenthesis, positive or negative? -8, 2. -5. Bracket or parenthesis? Bracket. Then we go from where? Parenthesis, -5, 2. -2. With a bracket, yes? What's the next one? -2, 2. to 2 with the bracket. Then 2 to, what is it? 4. Then 4 to 6. Ooh, very good. Why is it infinity? Because there's no endpoint. It just keeps going. Make sense? Well, that was easy. All right, what's next? We did steps, so now we have to do piecewise. The less you participate, the less that it's actually going to go in your noggin. Just so you know. I'm going to tell you what the points are. You ready? When you're done with your graph, I'm going to tell you what the 2 points are. Are we ready? Okay, your first point you're going to graph is going to be 1, 2, 3, 4, 5, 6, negative 6 comma 0. Next point you're going to graph negative 4, negative 5. Next point is negative 2, 0. The next point is 0, comma 3. The next point is 2, comma 0. The next point is 3, comma negative 2. The next point is 4, comma 0. Okay? We're going to connect these dots. Here we go.
What's the first one again?
Negative 6, 0. Ready? All right, and question 1. Identify intercepts. It says estimate if needed, but identify intercepts. Question number 2. Identify the intervals of increase and decrease. Oops. Question number 3. Identify intervals of positive and negative. And question 4. Locate any relative maximums or relative minimums. Also, if you think you just have to get through IM2, all of this is first semester of IM3. God bless you. Ready? All right. Identify intercepts. Which ones do they want? X-intercepts or Y-intercept? Does it matter? Nope. Bless you. So let's give x-intercept first. Where's your x-intercepts? Is there more than one? What are they? Comma 0. What else? Very good. Also? And? Good. All right, y-intercept, what are they? Just 0, 3. Okay, next. What does it ask for? Intervals of increase and decrease. Is this review? Yep. Where are we increasing from? Okay, let me label. From here to here is what? And again from here to here. And then from here to here. Increase and increase. Let's go from left to right so people don't get lost because some people are still lost. And it's now week 5 of graphing, I think. All right, from increase, let's do this. Is this increase or decrease, you just said? Decrease from where to where? -6 to? -4. Then we go from where? Increase from where to where? -4 to? 0. And then we go what? From where to where? 0 to 3. And we increase from?
3.
Very good. If you put brackets, it's fine. You put parentheses on this one, that's fine too. Either one is fine. Okay? Doesn't really matter. Got it? Okay, positive, negative. Positive is located where? Above the x-axis. Negative is located under the x-axis. I feel like a broken record. All right, so let's label. What is this again? You said negative? So from left to right, the negative from where to where? -6 to -2. Then we go where? Positive from where? -2 to 2. And then we go negative again from where to where? 2 to 4. Good. Okay, next. Relative maximums or relative minimums. Now, when you had a vertex for a parabola, you had max and you either only had one max or one min, right? Okay. This one has multiple turning points. Yes? So can you have more than one? Yep. So let's list relative max first. What is your relative maximum? Is there one or more? There's just one. Where is it? 0, 3. Very good. And then you're going to tell me relative minimums. Is there more than one? Yep. How many? 2. What are they? What is it? -4, comma. It's 5. -4, -5, and then again at what? +3, -2. Okay, that was fun. Next. Say it again. We are going to do exponential in a second. I'm going to do one more of those. You want to let that person in because I don't know who it is. Sarah? Was she? Oh, she's in the thing. Huh? I'm totally excited. It's Sarah. Welcome back. I didn't see her. Like, when they knocked, I literally couldn't see anybody. That's why I said. I was like, whoever it is, you can get the door. I don't see them. I think you can see because you can see out the window. But from here, I couldn't see at all. It just looked like nobody. All right, here we go. Graphing the point. You ready? Two comma 0. 0, negative 5. Negative 3, negative 3. That's it. Now watch. We good? All right. Answer question 1, 2. Same question. Yep. Ready? Kinda. X-intercept is what? 2, 0. Y-intercept is what? 0, negative 5. Increasing. Well, let's highlight. From here to here, is that increase or decrease? Increase. And then again from here to here, yes? All right, we are increasing from where to where? Wait, there's no end point. Negative what? Very good. Negative infinity to what? Negative 3? Yeah. Good. And then again from where? Negative 5 or 0? To infinity? Is correct. All right, decreasing from where to where? Negative 3 to 0. Okay, positive. Where are we positive from? We're positive from 2 to infinity, and then? Negative infinity to? Very good. Okay. Relative max? There's only one. Negative 3. Negative 3. Relative min? There you go. Perfect. Exponential, here we go. All right, our exponential function is going to say f of x equals 3 to the x plus 2 plus 1. Don't forget our starting point is always where? 0, 1 is always our starting point. Don't forget h tells us what? What does h tell us? Horizontal shift. Now we're looking at that 2, but if that's a positive 2, is it really positive for us to shift? It's what kind of 2? Negative. So is that left or right? Left how many? 2. K is always the same, so what's that K tell us? Up 1. Very good. Is it growth or decay? Growth. How do you know it's growth? Because it's 3. All right, you ready? Watch the magic. I want you to watch, because then you're going to get stuck. You're not going to know. Starting point is always 0, 1. Yes? That's always my starting point. It says I'm going to go left 2. So from my starting point, I'm literally going to go left 2. There's 1, there's 2. Then it says I'm going to go up 1. So there's my new starting point. My axis, my asymptote is at what? At 1. So there's my asymptote at 1. I'm going to graph this. Watch it, close attention. There you go. That's it. You should have learned how to graph this last year, which is why I'm just adding horizontal and vertical shift. Mainly horizontal. Go ahead. Oh, graph it. And while you're graphing that one, I'm going to give you another one to now graph. Identify whether the H is what, the K is what, and then if it's growth or decay. What's your H? What's your horizontal shift? Right 4. What's your K? Up 2. Growth or decay? Decay. Why? Because it's less than 1, your fraction. All right, so let's take our starting point from where? Where's your starting point? Always 0, 1. Take it which way? To the right 4. There's 1, 2, 3, 4, but then take it up 2. So there's my new point right about there. Draw in your asymptote at what? At 2. And growth. So I'm going to change my color. I mean decay, sorry. Like that. Should I cross the asymptote? Nope. If I cross it, am I wrong? Yes. What do you mean left or right? Does he do opposite? Does he go opposite? How do you know if it's decay? Fraction, less than 1. Not negative, but fraction. Your homework is 2 sides. Yes, you're going to do all of it. The front should be relatively easy on the first part. The back should be easy. The hard part is going to be the 4 questions on the 4 through 8 on the front. Or 5 through 8 on the front. If you need help, you can ask me for help on Remind, and I will see you tomorrow.